What's good, guys? So in this video, we're gonna be making a Parry system. Now, I just decided to make this video because it's so simple to make, and I know that these games with Parry systems are becoming very popular. So this is how I would make it. I've never made one before, but it is pretty simple. So we'll just do a server script right here and call it Parry, I guess. You can call it whatever you want, like Monkey Bones or something. I don't know. But what we're gonna do here is we're gonna have a table. Okay, so we're gonna have um has parried. I don't know how to spell parry, to be honest. Has parried. Um, you can name it whatever you like. So we're gonna have two tables, right? So has parried and is parrying. Okay. And what we're gonna do is we're gonna create a like on server event. Now I would usually use com for this or maybe knit or whatever else that I would use for this, but we're just going to use a regular remote event. So we could even instance it. We don't even have to create it inside. So we'll just do Parry event. Okay. This could be actually a remote function, to be honest. Now that I'm thinking about this, this could be a remote function because we want to send information back to the client. So yeah, this could be a remote function. So there we go. And then what we're gonna do is honestly, I forgot how to like set this up again. Because I've been using knit for so long, I forgot how to use a remote function. Let me think about this real quick. Let me see if I can remember off the old brain. Okay, instance, remote function. I'm actually going to create this above here though, just because I like to organize my code like that. And then we got to parent it, Parry function dot name equals Parry function. We're going to also get the replicated storage because that's where we're going to parent it. Because this is where we would get it. So we would be able to now access this from the client script, right? Using wait for child on the client. Set Parry function. So I Parry function dot on server invoke. That's it. There we go. Connect. And then we'll be super clean with it here. So local function on Parry player, and then we'll just send the player in for now, right? So we'll do on Parry, and then what we can do here is if table.find, or actually, yeah, we'll do if is parrying player, then return player is parrying. This should work. This print should work, I feel like, but it might not actually. So what we'll do is we'll just put it before. I feel like that print's just not even gonna work. I can't remember. Not that big of a deal though. Player is already parrying. So what this is doing is if the player is already in the is parrying table, we're not going to parry. And so we're just going to return false, meaning that he did not parry. So we could even do this. We could even do now you're thinking, why do we need to create a whole variable for this? Well, because now it's easier to read. If we're going through our code, it's very, very straightforward of what we're returning here. We're not just returning false, we're returning did not parry because that's what false represents. Anyway, so now we can go in and do down below, we can do is parrying player equals tick, and it's like tick is like outdated now. Now you want to use like I think os.time, but I'm just gonna use tick for this video. So we're also gonna have a vary of here. So we're gonna have a variable here, parry length equals parry length. What should we have parry length equal? Maybe like 0.5, you know? Because we don't want it to be too easy to parry. Or maybe we do want it to be too easy to parry. So we're just going to put it to 1. I don't know, dude. Whatever you want it to be. And now we have is parrying player equals tick. And then we have, let's see. That's what we're going to do for that. And then we can say return true, as in he is parrying, return true. Now what we're going to do is we're going to have a remote event. So parry off event equals instance.new remote event. Parry off event dot name equals parry off event. Whoa. Yeah, I did not need to do the local there. Then we can have parry off event dot parent equals replicated storage. And then now we're gonna get run service real quick. So run service equals game get service run service. And then what we're gonna do here is we're going to create another function on heartbeat step. I think it's step, right? I don't know, we'll see. Run service dot heartbeat connect on heartbeat. And then so what we're gonna do here is for every player, time, not time, I'm not gonna do time for every player, stamp, the timestamp in is parrying do. All right, so we're going to be looping through the is parrying table. Okay. Hold on. Why did we need has parried? We don't even need has parried, honestly. Yeah, we don't even need that second table. I may have misspoke. So what we're going to do here is we're going to say local time elapsed equals, I believe it's this. I believe it's tick minus timestamp. And we could do timestamp, or we could just do start parry or something like that, but it's like whatever, you know, and time elapsed, and then we can say if time elapsed is greater than our parry length, then, all right, and then we can do if time elapsed is greater than our parry length. What we can do here is greater to or equal to. What we can do here is parry is parrying player equals nil, and then we can say parry off event fire client player. Now, what this is going to do, and say we have other code around this. Say like when this is trying to run, we have other code that also could be accessing this and also making it nil at the same time. So what we could do is add in some defensive programming to prevent any errors or bugs that may cause. And then just do if it is there, then we can make it nil. Okay, so if the player is in this table, we will make it nil, even though they will be in this table by the time we go through our loop. And you know, if this code runs, they're in the table, but this could get here, and then the slightest chance, an edge, maybe possible edge case, could be that it is nil, because say that somebody is parrying and the parry was successful, we want to turn the parry off during that successful parry. This is not doing that. This is only turning it off when they've reached the parry length and they are parrying. Okay, so that is something to keep in mind here. So that's why I put that there. Defensive programming. This will keep you from having potential bugs that may cause, or errors that may cause. All right. So, and we could also put this there too. Because because we only want to do the event if it's, you know. And I like to separate these lines. The reason why these lines are being separated, right, is because this is a remote event firing. This is we're making the player in the table nil. I separate these lines for organization, okay? These lines are different. They're doing different things. They're not the same. So if I had another table and I was making something else nil or turning something else true, then I would keep that with this. I would group it up with that and put it right under here, right? But these are completely different things, even though they're all part of the same mechanic. So it's just organization that I like to do. Let's see real quick. What was I thinking about? Okay, so this is a heartbeat that runs now. Now we activate our parry. We're gonna get put into this function is gonna run when our parry is gonna be activated. It's gonna do is put us in a parry table and give us a timestamp when we started our parry. This heartbeat is going to run every heartbeat, which I believe is every in-game frame. I'm not really sure. I'd have to go look at the documentation. And we would, if we are pairing, it's going to check our timestamp. And if our time elapsed is greater than this, then it's going to run this chunk of code, which if it is, it's going to turn off our parry. Okay. And then that's what we're doing there. And why we're shooting this off to the client is because um, we're shooting this off to the client because we want if when we turn off our parry, we have animations running when we're pairing, right? This is going to let us know to turn off our animations and do whatever else we need to do. So it's just important that we send this information back to the client. Now this, why do we have this return true? So we can create another constant variable, which is parry started. So this is just letting us know we're returning true because this is a remote function. We're just letting it know that we want to um that we want to let our client know like we started our parry and then this is did not parry. So we could actually have this as did parry just to keep it, you know, like very similar and just very consistent. So just part of organization and stuff, and it just makes our code very readable. So I mean, I feel like a somebody that doesn't know code too well could hop on here, and if they read the variables right, and they're able to just read very clearly, they'll be able to understand kind of what's going on. And so that's why I'm writing code like this. Now this is the parry system as far as, you know, player sends it over from the client. I'm not going to get too far into that because that is super simple. All you do is, I'm not going to create the local script for that because all you do is you create a local script. You do wait for childs for these events on your local script. You activate whatever it is action keybind that you're using to you know activate like what like if it's a button on a joystick or if it's a mouse and it's left mouse button, you activate that, you grab that event and then you're just firing off this remote event, this remote function, okay? And this is something that is so super basic that literally Roblox's AI could just poop out real quick for you. How do I create a remote event for this? Boom. There it is. So, or a remote function on the client side. Like, what's a remote function on the client side look like? So I just feel like I don't need to set that up. Now, what we can do is we can add an attacking bit. So this is only going to be the server side. I'm not gonna I'm not going to make you know, anything that is client side in this video. I just don't feel the need. Attack. So we could have an attack function here too. Could have an attack function. Because we want to send information back to the client when a client is trying to access their attack. So this code is set up to prevent exploiters as well. That is why I'm making stuff the way it is, to prevent exploits from happening in game. So we'll have attack function. And then now I'll also be able to show you why I did this part right here. If is pairing player, okay? So that'll make complete sense once I set this up. Okay, so if is, and we're just doing, and it's the same, and it's really the same code, the same type of debounce, what we're doing. It's the same logic. There's nothing different really about this. It's just now we're doing an attacking system. We're not doing a parrying system. So you're really going to see that it really is the same logic here. They're just going to be doing different things. You know, like when we get down to the VFX on the local scripts, or when we get down to taking damage away from the other player, because attack would be taking damage away from the other player. This would be saying that no, you can't take damage away from the other player because he's parrying. So it's stuff like that. And it's really not super complicated to make stuff like this. It's just checking stuff and having those tables and using them properly. So if attacking player, then and then we'll have whoops. Then we'll have some more constants. So is attacking or did attack or was attacking or wait, yeah, is attacking hold on. Let me see what I was gonna say. So is attacking if is attacking player, then we'll have if is attacking player. I'm losing train of thought here. I'm not like trying to think of what I'm gonna do. I just lost complete train of thought on what I was doing. So yeah, is attacking if is attacking player, then what was I even gonna do here? I forgot. Oh yeah, okay. Return false. So we'll have cannot attack. So we'll have cannot attack. And then we'll have can attack. And then we're just going to switch that. All right, cool. So cannot attack. We'll do a print statement here. Player is already attacking. I can't believe I just lost train of thought like that. That's so goofy. And then we'll just have is attacking player. And then we'll do is attacking player equals tick. So we're just gonna do another tick. And then we'll do return can attack. All right, so and then we'll have this. And as you see, also everything is in complete order. Everything's in complete order. My attack function is being made first. My attack remote function is being made first. My attack function on the server invoke is being made first out of all these. You know what I mean? So everything's in order. So on server invoke, connect on attack should be right. And then yeah, so now there's different logic that goes into here. Now it's of, you know, let's say a player is hitting. Now we can have raycast on the client, we can have raycast on the server, however you want to do that. But let's just say that we have the raycast on the server and we detect a hit, okay? So I'm just gonna write out in sudo how that would look, all right? And then again, it's the same. I'm not even gonna go further because it's the same. As you can see, these are the same function. These are the same function handling two different tables. But we need these two different tables because these two different tables are two parts of information that we need to know. Okay, so that's just what we need. Now, we could even probably come up with a function that handles both of these two tables one at a time, handles them each, whatever. We could probably do that, but I'm not going to. It's not that needed. But anyways, I'm like getting off track here. All right. So, what was I gonna do? Oh yeah, pseudocode for the if somebody is attacking, right? And then so what we would do is raycast detected. All right, let's say raycast detected. Okay. Then we're gonna say if is attacking, then okay, and now we're gonna get the two arguments for the raycast. I don't want to make this a raycast video. This video would be very, very long. This was just logic for the parrying itself, right? Not the raycast. If you guys want a raycast, I don't even know if I want to make that video because it would just be so probably incredibly long for me to explain everything outright. So this is just the parrying logic right here, okay? How we're handling players that are parrying and stuff like that. But let's say if is attacking, okay? If is attacking player, and we will have these arguments from our raycast. We will have these arguments from our raycast, okay? We will get these arguments from our raycast. But let's say if player attacking, okay? We'll have player attacking, if is attacking, player attacking, and then we'll have if is parrying player attacked or player hit, but let's just say attacked for consistency. If is attacking, if is parrying, then don't deal damage. And then we'll have the remote event for successful parry event. All right, well, this will be a remote event for this. Okay, successful parry event, right? Now then we're gonna fire that and say, hey, this was a successful parry. Okay, so fire successful parry event, and this would be for you would shoot this down for both, okay, for both players involved. Okay, so that is the player attacking and the player attacked. And then you could have an else here. Else, we're going to deal damage, okay, and then you could have another event here. So you could have what's the other event? Successful, yeah, just successful attack. So you could have successful attack, okay. I'm just creating this so you know that these are remote events, okay? And we're only using these to communicate certain information, right? And we're going to access all this on the client. So then you're going to have, fire successful attack event for both players involved, right? And then this is also going to be in our raycast function. All this is going to be in our raycast function when we establish an attack has been made or raycast is there, blah, blah, blah. And also the raycast actually would be in here if we're doing raycast on the server. That is very important. If we're doing raycast on the server, because we can do raycast on the, we would start our raycast here on the server. If we're doing it on the server, You know, and so, but this little bit would be inside. Okay, we would have more code here. It would be inside of our raycast if we're doing it on the server, right? But yeah, and then there you go. And then now it's important to note that what we would do here for this is remove players. Remove players from tables. All right. And we would want to do that. So remove players from tables. And then we can go a step even further. So we can actually do this part. We can do this part. So this isn't very, this tutorial is not getting beginner friendly. It's getting like very unbeginner friendly at this point because I don't feel like taking the time to create everything from scratch. And I'm just going over the pure logic here. But let's say we're doing remove players from the tables. Now, in order to prevent bugs from happening, because let's say we are removing players from the tables, right? But we're still doing other stuff here. It's still committing, you know, we're getting rid of animations, we're doing all this other stuff. You know what I mean? So what we could do is we could remove them from the tables last. We could just do that. That might actually, now that I'm thinking about it, uh that might actually work and do what we want to do and everything would be smooth. But in certain situations, you're gonna want to remove them. It just depends if you have a ton of other stuff going on or how much other stuff you're going on or what the exact situation is. Sometimes you're gonna want to remove them from the tables sooner. And then we would have like a, you know, limbo table in limbo, right? A limbo table where you don't want them in these tables, but you don't want and like I said, it might not actually be for this situation. It really might not. It's just something that I'm thinking about. It just depends. Like, you know, there's so much, sometimes there's so many things that are going on, but you might want to have a limbo table sometimes. It just depends. So in that case, what you would do here is you would check, or if in limbo, you know, or if you want print statements, print statements to change, right? Then you can do more if statements on top of that, or however you want. There's so many different ways to do it, but you would have here, you know, if in limbo player, we're not going to run the parry. We're not going to run the parry. We don't want them to parry. We don't want them to be able to attack. Again, we would go down to our attack function. If they're in limbo, we don't want them to do anything. Okay, so it really, for this particular situation, off the top of my head, I'm thinking that just doing this at the end after all of our stuff is done would work. But actually, no. And that's what I was thinking. Okay, so because we have this heartbeat function, we don't want, this is only for if an attack is unsuccessful, an attack doesn't even happen. This is only for if a parry is happening. If a parry is happening and nothing else has going on, this is what this is for. It gets rid of the parry and shuts off and does whatever it needs to do, right? That is why. So I'm right on this. So we do want to remove them first, and we do want to put them in the limbo table because we want to play out whatever's happening after the attack. We don't want an attack to happen after. We don't want an attack to happen after an immediate situation has occurred, okay? So okay, let me just, after an attacking situation has occurred, whether it's been parried or not, whatever, we want to put them in this limbo table. You can call it something better than in limbo, okay? But we want to put them in that limbo table because we do not want them to be taken out of any other table. And obviously we would have another, we would have in our heart, we would have another for loop here in the same heart. You can do this in the same heartbeat. You can do this in the same heartbeat. We would have another table here, like for player, timestamp in is attacking. Do, okay? So the same situation is going on here, okay? Now we don't, if the attack is successful, if something is happening, okay, if conflict is happening between two players, we don't want this to run. We don't want this to run, but we also don't want them to be able to attack or parry immediately after a conflict has happened. Okay, so we're going to have them in limbo for however long we would have them in limbo. And again, we can also go through here and say for player timestamp in limbo do, and it would do that. And then if we really want these to run separately, we can just have task.spawn function. And now we're just wrapping these. We're just wrapping these in a task.spawn. And then sometimes I don't know, I can't remember if heartbeat, if we need to wait, if do like a little task.wait or do a little you know, render. It's like a, I forgot what it is called, but it's I think it's an event or something of that that is the frame or whatever. Can't remember, but yeah, we would just wrap each for loop in a task.spawn if we found that they need to be separate. But yeah, that is that situation here. So that is pretty much an advanced like parrying system, how I would do that. I hope all that makes sense. Let me know if that made sense for you guys. In order for me to do all this from scratch, it would probably take quite a bit, and so that's why I didn't, and that's why I did pseudocode. So if you understand the very, very basics or beginners of coding, then you probably will understand a little bit about what I'm talking about, especially because it's, you know, I'm using clean variables for you guys. And yeah. But all right, guys. See y'all in the next one.